All right, Algebra 1 students, more equations practice. We're going to do some literal equations, we're going to do some other equations, and we're going to do some special cases. So you have a couple good examples in your notebook for those. A student brought this comic to my attention. It's kind of awesome, so I want you to read it. And if you know, okay, pause it if you need to, because I'm not going to hang out on this slide for like a minute and then jack the time on the video up. If you know this cultural reference, I want you to send me an email or an iMessage tonight telling me what this cultural reference is. Don't cheat. Don't ask your parents. I want to see who knows and who doesn't. I want you to see who knows this cultural pop. That's supposed to be an arrow, and it looks awful. Let's try that again. This cultural, this kind of pop culture reference from the 70s and 80s. Okay? All right, don't cheat. Don't ask your parents. I want to see who knows. All right, let's get started. All right, so we're going to do some literal equations practice first. So we have n equals 4/7, n equals 4/7 m plus 12. And we're going to solve for m. So first, remember I'm reversing the order of operations. So think about what happened to m. m was multiplied and then 12 was added. So what do I have to undo first? The added 12. So n minus 12, I can't actually do anything with it. I just have to write n minus 12. And then I have 4/7 of m on the other side. So now I want to get m by itself. I'm going to use the multiplicative inverse property. And I'm going to take this and I'm going to multiply both sides, multiply on both sides by the reciprocal, which is 7/4. And here's the great thing about doing it this way. You may think that this looks daunting. You don't actually have to change anything. You can actually leave it just like that. So 4 and 4 cancel, 7 and 7 cancel, so we have 1 m on the right, and we're done. 7/4 times the quantity, n minus 12. Now, if you had 7/4 n minus 7/4 of 12, well, 1/4 of 12 would be 3, so 7 would be 21. You could also express it this way. So if you're doing that pause it, try it, and then play it thing, you could have either answer, but you can actually stop at the one in the box. All right, there's one literal equation down for you. Let's do another one. V equals LWH. You should recognize this as the volume of a rectangular prism. Okay, that's about my drawing ability right there. So there are commonly formulas like this where it's all multiplication. Another common one is your interest formula, which is PRT, I equals PRT. We'll see some practice problems with that later on in the year, or actually in a couple of classes, really. But equations like this, it's all multiplication over there on the right-hand side. So if I'm solving for h, like it says right here, I can divide off both of the things that are multiplied, and I use cursive L there, and the cursive W is just out of habit. So they cancel, and you can divide both of them at the same time and have one big fraction. V over LW equals h, and we have h alone. Think about the usefulness of that. If I know the volume and the length and the width, the volume, the length and the width of a prism, I can find the height. It might be useful, you never know. All right, let's keep going. Okay, in this one, D is really in there. It's really in that equation. It's inside parentheses, and it's being subtracted, and it's just all kinds of difficult. So we got to work our way backwards through this one as well. So A equals B times the quantity, C minus D. So the first thing I need to undo is the outside of those parentheses. I'm going to divide off the B. I don't want to distribute, because distributing will make it more complicated and harder to solve. If I divide off the B, I now have A over B equals C minus D. Now this is a little tricky because D is at the moment negative. So we're going to do something we don't normally do. Rather than subtracting this C right here, I'm going to add D to both sides so I can get it positive. That gives me A over B plus D equals C. So I added D to both sides to get the D positive. Now I can isolate the D by getting rid of this term, and I can subtract A over B. It's just like subtracting a fraction. That gives me D equals C minus A over B. That one was tough, but think about what we did. Okay, D is subtracted from C, and then the result was multiplied by B. We had to get rid of the B first by dividing. Instead of subtracting C and causing a negative nightmare for ourselves, we're going to add D first to get it positive. Then we subtract the A over B, and we're done. Next problem. All right, this should be a familiar formula. This is the formula you use to convert Celsius temperature to Fahrenheit temperature, excuse me, I have the hiccups. Celsius temperature to Fahrenheit temperature. So we're going to use our order of operations in reverse here. We're going to subtract the 32 first. So F minus 32. This should look a lot like our first example in our notes. So take a second, pause it, go back and look at that first example. What should you do now to get C by itself? I'd pretend that I heard someone say it, but I can't hear you, which is probably good because I don't know what you're doing when you work on this stuff, you know, private time and whatnot. We're going to multiply by the reciprocal. The 5's cancel, the 9's cancel, and we just get C on that side. Okay, woo, a messy C. Let's fix that. Just C. And again, leave it. Leave it. It's F minus 32. So 5/9 times the quantity F minus 32. Think for a second, what's the significance of the number 32 in this formula? Let's think about that. Think about that, science peeps. Think about that. Tell me in class. Okay, tell me about it in class. Next one. On to regular equations. So yes, we've got some ugly fractions to deal with here. I am going to start off by distributing, and then I'll get rid of my fractions. So I want to distribute first to make things a little bit less complicated. Negative 3/4 of x is negative 3/4 x. Negative times a minus 8 is going to become a positive right there. Negative times a minus is going to be a positive. 3/4 of 8. Well, 1/4 of 8 would be 2. So 3/4 of 8 would be 6. And over here, half of 6x is 3x. And then we got 5/2. Then we got 5/2. So now I've got fractions, and I don't want fractions. I'm going to get rid of them. What am I going to use to get rid of them? The least common denominator of those fractions, which in this case is 4, because 2 does go into 4. If I now multiply everything by 4, what's that going to give me? Well, here the 4's will cancel. Here the 4's cancel, and we get negative 3x. Here, 4 times a positive 6 is plus 24. Over here, 4 times a positive 3 is plus 12x, or positive 12x. And finally, 4 times 5/2. 5/2 of 4. 1/2 of 4 would be 2. 5/2 of 4 would be 5 times 2, which is 10. And now it's just a variables on both sides equation. So we're going to continue with the work by adding 3x to each side because negative 3x is smaller than 12x. Remember, that's a good way to start, especially because sometimes we get stuck with the problems. We got 24 on the left, 15x plus 10 on the right. Subtract 10 from each side. We get 14 equals 15x. Remember not to panic, just write your division so you can see your answer right there. X is 14/15. Now I'm not going to make you check that, I've already checked it, but we are going to check the next one. In fact, I'm actually going to ask you to do it on your own. But this one is pretty hideous. Remind me in class, let's go over checking that on the graphing calculator. TI-84 plus graphing calculator. All right, 3 more problems and we're done with this video. All right, this one. So distribute. If you're getting comfortable with this, pause it, do it yourself. I'm going to go ahead and start writing it out. Negative 7d minus negative 14. Remember, that's a plus 14 right there. Plus 18. Oh, random stuck togetherness there. Sorry. Negative 5 times 2d, negative 10d. Minus 5 times plus 2 is minus 10. What's smaller? Oh, nope. Hold on. Combine like terms. Gotta combine like terms first. So negative 7d plus 10 and 10 is 20. 4 and 8 is 12. So 32. Now I can get rid of my variable. Which one's smaller? Negative 10 or negative 7? Negative 10 is. How do you get rid of a negative 10d? You add 10d to each side. Add 10d. That's going to cancel there. We're going to get 3d plus 32 equals negative 10. We're going to subtract 32 from each side. Undoing our addition and subtraction before multiplication and division. Please be careful with your integer math. Use IXL and practice those integers if you're struggling. Divide both sides by 3, and d equals negative 14. Check that for me, if you would, please, by plugging it back into the original, but I'm not going to do that in the video. That's on you to check it, please. Last 2 are the special cases. Let's look. Special case is called an identity. It's called the identity, and it gives us an infinite number of solutions. So let's go ahead and do the math here. Distribute 20f. plus 8 minus 2f equals, I'm going to combine like terms here, 18f plus 8. And here, 18f plus 8. Now I should clearly recognize that something has gone awry. Something is amiss. Sorry, I've been watching a lot of Doctor Who, so all the Britishisms keep coming out. But something is clearly really weird here, because it's exactly the same thing on both sides. If I was to continue, I would get all the way down to a statement like 0 equals 0, or f equals f, or 8 equals 8. And those are all true. Which means that this equation is an identity, and it has as its answer its solutions, all the real numbers. And this is what you would actually write on your paper right here. So that's an identity, okay? It doesn't matter what number you plug in. You can plug in 4 billion, it's still gonna work. Okay, let's take a look at the last one. Equation with no solution at all. So distribute, double rainbows all around. Multiplying that, we get 10a plus 15. And here we get 10a plus 2. So again, something is wrong. Something is clearly wonky with this. If we keep going, we're going to get answers like 10a plus 13 equals 10a. Well, that's not possible at all with any number, not even 0. Or we'll get 15 equals 2. Well, these are wrong. These are clearly wrong. That's just in general, that's a false statement. And that's what tells me that I have in my equation here, with my equation, no solution at all. And you can write that several ways. You can write a circle with a line through it. It's called the null set. You can write the curly braces with nothing inside them. That's also called the null set. Or you can actually write the words, no solution. Which brings me to the end of your practicing equations video. Remember that your skills to help you with this on IXL are J.6 and J.7. If you prefer Khan Academy, email me and I will send you some links. Thanks, guys. I'll see you in class.